So I want to introduce you today to the Chemis-tree. One of the things that you need to pay the most attention to when you're writing electron configurations is the Aufbau principle. And the Aufbau principle says that electrons fill orbitals of lowest energy first. So then the question that logically comes out of that is, well, which orbitals are lowest energy? Well, if this were the Bohr model, it would be simple, right? N equals 1, 2, 3, 4, and so on. But it's not the Bohr model, it's the quantum model. And we not only have energy levels, but we also have sublevels. And those sublevels have different amounts of energy. And so you might see a diagram like this in your book that kind of shows you which orbitals have lowest energy. And this is a little overwhelming to look at, right? So if we look at this, we have the 1s, and the 1s is always going to fill first because of we know that because of the Aufbau principle. Right, the Aufbau principle says that electrons fill orbitals of lowest energy first. So the question then becomes, well, how do you remember the order that they're filling? So you could look at this diagram, right? 1s, right? We're increasing in energy. 1s is the lowest energy and 6d is the highest energy. And then so we go from 1s to 2s to 2p to 3s, 3p, and on, right? You can see if we follow this order going up that it's going to be in lowest energy to highest energy for the Aufbau principle. But that's a little hard to remember, although you guys should definitely have this in your notes. I don't think this diagram was in your book, and so you might want to pause the video and take a screenshot of that or something. You don't need to copy that into your notes, however. This next stuff, though, I think you should. How do you remember that filling order? Well, I've got a simple way. I call it the Chemis-tree. You'll see why here in a minute. And you have a couple prerequisites here. You have to be able to count 1, 2, 3, 4, 5, 6, 7, maybe even up to 8. You have to remember SPDF. Now, I have a simple way of remembering SPDF. Stupid people die first. I know it's a little harsh, but it is what it is. So if you can remember that, you're in good shape. These next prerequisites might eliminate some of you. You have to be able to write neatly. Sorry, Reed, but you're going to have to work on it. You also have to be able to draw straight lines. So hopefully many of you will be able to do this. So here we go. I'm going to start just writing the orbitals: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, and 4f. Now I'm just going to kind of make a mirror image of this. 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7p, and 8s. I could go on, but because technically there are more than 3 orbitals in the 6th energy level, more than 3 sublevels in the 6th energy level, same for the 7th and the 8th, but we'll just leave it here. I'm going to change my pen color. And now, so that was the neat handwriting part. Now comes the straight line part. So I'm going to make diagonal lines through all of these. And as we follow those diagonal lines, that ends up being the filling order that electrons go into atoms. So if we follow the green lines, the first line goes through 1s, then I come back to the beginning of the next line and I go through 2s, then I come back to the beginning of the next line and I go 2p, 3s, then I go to the beginning of the next line, 3p, 4s, 3d, 4p, 5s, and so on and so forth. So let me finish out the Chemis-tree here. I need to put a base on my tree. And then, of course, every Christmas tree has an angel on the top. So there is my chemistry, my way of remembering the filling order of electrons in atoms following the Aufbau principle. So now your book has something like this, which is kind of the same thing. They put the nice little dashed lines in there to tell you that, yep, goes 1s, and then, following those around, it's kind of this zigzag thing throughout, and that's helpful too. But sometimes it's good to rewrite it and think about it maybe a little differently. And they stop at 6D. Technically, we can go on beyond that. I don't know why they chose to stop there. But I hope this was helpful, and be sure to come to office hours with questions if there are more that you have beyond this.